Welcome to my final year project demo entitled Traffic Sign Recognition System using Deep Learning. The video is broken down into different parts. Firstly, I will talk a little bit about the aims and the objectives of this project. Then I will proceed with the dataset chosen and the training of the model. I will also explain how the system works, and finally I will run the Python script and show some testing results of the system. Here are the contents of the video. So the aim of this project was to develop a system that can perform detection and classification of traffic signs in Mauritius, which can be a way to reduce road accidents here in our country. I developed an application that allows the user to upload a video and perform a classification of traffic signs from the video frames. The objectives were to collect traffic sign images to construct a local dataset for traffic signs, train the system with the images gathered, develop a graphical user interface to accept user input, develop a system to detect traffic sign effectively and classify traffic sign accurately, and also to evaluate the performance of the system using different scenarios. So, in all machine learning projects, the dataset is one of the most crucial parts to achieve a good classification. So it was important to have a good dataset, a quality dataset. In my case, I was doing deep learning, and in order to perform deep learning, we need a massive dataset with a large amount of images. After gathering local images and merging it with an existing dataset, namely the German traffic sign dataset, my constructed dataset amounted to around 24,000 images for 41 classes of traffic signs. The gathering of the local images was indeed a tiring job, but thanks to my friends and relatives, I managed to get a decent amount to conduct the learning. So for the training, after the dataset has been cleaned and the outliers have been removed, the dataset was ready to be used. I conducted a supervised learning using convolutional neural networks. CNN is very good at doing image classification, and it is widely used in image classification projects. So after doing my background study and literature review, I went for CNN. During the training of the model, we use filters to detect and extract patterns in images. So the filters are small matrices, usually 3x3 or 5x5, that are used to detect patterns. They are also referred as kernels. We slide the kernels on the entire image and pass on each pixel and transform the image. This process is what we call convolution. As you can see here, I have my kernel here. Okay, this is my source image. We slide over the entire image and transform the image. So here we get the result of the convolution for this particular pixel. The result of the convolution is then passed to the next layer in the network. In the network, we perform convolution on the image several times, and features like edges and corners are detected using the kernels. Deeper in the network, we are able to detect complex features such as objects. After performing 15 epochs, we had a stable accuracy of 99%, of around 99% on the training images. After the learning has been done, we save the model. So the system consists of two phases, a detection part and a classification part. Before we can perform classification, first we detect the traffic sign. So for the detection part, we use a color and shape-based approach to detect the traffic sign. So the idea was to use the common shapes of traffic sign and colors for the detection. As you can see, we have triangles, squares, hexagons, circles. So we use these shapes to detect the traffic signs. So when we read a frame in the program, we convert the frame to HSV color space, then we segment the image. We apply contour algorithm to detect the potential traffic signs. And after we get the traffic signs, the potential traffic signs, we crop it and it is ready to be passed through the network. For the classification, first we need to pre-process the crop region of interest. So we convert the images to grayscale, apply histogram regularization to adjust the contrast and improve the image. Then we normalize the image. Then after that, the image is ready to pass through the network. So here we can see how the system works. My input image here, then we pass it through the graphic sign detector. After detecting the shape here, we crop the region of interest and pass it through the classification network. Here, this is my output. We got a stop sign here in this example. Here's an overview of the system. As I mentioned before, I have my dataset and I conducted my training and extracted the features and saved it to the model. Here I have the input. I segment the image, detect the shapes, crop the region of interest, pre-process the region of interest, then pass it through the classifier. Then we are able to obtain a classification for this traffic sign detected. So here are the features and functionalities of the system. This is what I implemented. The traffic sign can recognize the system can recognize traffic signs from the image, and you can also recognize traffic sign from real-time images and also from videos. There is also a voice notification for the traffic sign recognized. So let's now proceed to some testing and I will show some results. So as you can see, the Python script is already running. First, I need to activate my virtual environment. Then I run my Python script. So this is my GUI. I have a checkbox for voice notification, which is optional. And here I have different buttons for the different features. So let's try the real-time classification. As you can see, we have correct classification for the traffic sign showed. Now let's just activate the voice notification.
Stop. Network.
Now let's proceed to show some additional features.
Give way. No entry. Stop.
So as you can see, we obtain the classification for the traffic signs, and also the voice notification is working. Now let's upload some images. Now let's try with some dark images. I use this software to darken the image. So we're still able to get a accurate classification for these images. Now let's try some blurred images. So we are still able to get a good classification. So that's it for the video. Although the system is not perfect, we are able to get true positive for clusters of traffic signs that exist only in Mauritius, which has a position of pedestrian crossing. The system relies a lot on the detection. Therefore, if the detection fails, the classification fails. So, thank you for watching this video.